Welcome, learners. Welcome to Form 3 Chemistry. We continue looking at nitrogen and its compounds. So far we've looked at the sources of nitrogen, its properties, and both physical and the chemical properties. Now we'll come to a subtopic which is called the uses of nitrogen. So what is nitrogen used for in everyday life? Alright, so nitrogen is a very useful gas, as you might learn before. For example, it is used for the production of ammonia. So nitrogen is used for production of ammonia, and through a process called the Haber process, in which hydrogen gas reacts with nitrogen gas to form ammonia. Ammonia is NH3, which is also a very useful gas. Right? So we are saying one of the uses of nitrogen is to produce ammonia, but also nitrogen is used in food preservation. Okay, some foods need to be preserved using nitrogen. Remember that nitrogen is a very inert gas, meaning it does not react with air. It's an unreactive gas. So because of that, we can use it in the preservation of food. If you have bought a packet of crisps, like Lay's, if you buy yourself Lay's is basically a packet of crisps. If you try to squeeze the packet before you open it, you actually feel that there is some air in it. Okay, try to squeeze it. This is Lay's, which is crisps. Right? You try to squeeze it, you feel that there is some kind of air. The air that is in it is basically nitrogen gas. Nitrogen gas prevents the crisps from reacting with the oxygen, right? From reacting with oxygen, so that it does not go bad, it does not get rotten. If a hole is, let's say a hole is made into the packet such that oxygen enters it, the oxygen is going to change the quality of the food inside. Alright, so to make sure that only nitrogen is available inside, this has to be sealed as much as possible so that there's no entry of oxygen through any point. So the use of the nitrogen gas which is in it is simply to prevent the rays or the crisps from getting rotten. How? Because nitrogen has a property which is called inert. It is inert. Inert means it does not react with anything. So the packet is filled with such a gas to prevent it from combining with oxygen. Very, very important to note that. All right, another use of nitrogen is that it is used in oil tankers to prevent fires because of its inertness. Again, using its innate behavior, it can be used to prevent fires in tankers. If you have seen tankers are those that transport, they are huge vehicles that transport oil. Let's say this is a tanker, okay, a very big vehicle carrying oil. I'm sure you not have issues with my diagram. So let's suppose this is a tanker. This is a tanker, it's a car, transporting oil, fuel, such as diesel, right? Transporting diesel from somewhere, maybe Tanzania to Malawi here. This is a tanker. This is a tanker or a tank containing oil. So when they to transport oil, they don't completely fill it. They fill it up to a certain level here. Okay, so this is filled with oil, but on top here there is a gas. That gas is called the nitrogen gas. The nitrogen gas is filled here so that the oil is not exposed to oxygen. You know, oxygen is necessary for combustion. So to ensure that oxygen does not penetrate through the oil so that it can easily be ignited, they cover this top part with nitrogen to ensure that there's no contact between oxygen and the oil. If oxygen is in contact with the oil can easily catch fire. It can easily catch fire. So to prevent such fires, the very top of the oil is filled with, the top space of the tank is filled with nitrogen to ensure that the oil does not get in contact with oxygen, which is necessary for starting a fire. So this process of covering the oil so that it does not get in contact with covering the oil with nitrogen so that it does not get in contact with oxygen is called blanketing. It's called blanketing. It's like the oil is blanketed or covered with a blanket, but in this case it's not the actual blanket which you and I cover with when we are sleeping, but this one is nitrogen. So the oil is blanketed or is covered with nitrogen to prevent it from catching fire. So how the nitrogen is able to do that is because of its innate behavior or its unreactive behavior with oxygen. All right, so that's the use of nitrogen to prevent fires, in oil tankers. Liquid nitrogen is used as a refrigerant, that is very low temperature coolant. Okay, so nitrogen has a tendency to cool below 0 degrees so that it can be used for refrigeration. Some refrigeration or cooling systems use nitrogen gas. If you have been in the food section in shops like ShopRite, you find that when you get there, when you are walking around the food section, especially fresh food, you find that it's very cold there. That coldness is made possible because of the liquid nitrogen, which is used for cooling. Right. Liquid nitrogen is also used in shrink fit machines. Okay, shrink fit machines of machine parts is a process of joining machine parts. Okay, for example, that of bicycles, cars, and the other parts that need to be joined. They can be joined using shrink fitting. We'll cover shrink fitting a lot in physics when we are looking at thermal expansion, especially the applications of thermal expansion. All right. Having looked at the uses of nitrogen, let us now look at the compounds of nitrogen. We are going to discuss 3 compounds of nitrogen, namely ammonia. We have already said that nitrogen is used in the production of ammonia, which is a very useful gas. Okay, it is also used in the production of nitric acid and is also in the production of oxides of nitrogen, such as nitrogen monoxide and nitrogen dioxide. We shall look at the preparation of ammonia. All right, so ammonia can be prepared by simply heating what is called ammonium salt think about any ammonium salt, such as ammonium chloride. Ammonium chloride is NH4Cl, okay, with an alkali. Remember, an alkali is a base. It's a base which is soluble in water. A good example of an alkali is the calcium hydroxide. So calcium hydroxide, an example of it, is reacted with the ammonium chloride. So when calcium hydroxide reacts with ammonium chloride, the product will be calcium chloride, which is a salt. This is a salt, water, and then ammonia. Take note of the reaction involved, the chemical reaction. So calcium hydroxide is CaO2, OH2, and the ammonium chloride is the NH4Cl, and will produce a salt. This is a salt. Calcium chloride is a salt, and then there's also water produced as a byproduct, and then we have ammonia, which is the gas which is intended. All right, so from the reaction you see that there is water. So water is not desirable, therefore it has to be removed. So water vapor is removed from the ammonia gas by simply passing the gas formed through a drying tower which contains calcium oxide. So calcium oxide in this case is the drying agent used. It's called drying agent, whose use is to remove water vapor from the to separate ammonia from water vapor. So the setup, as you may wish to see, the setup is simply a simple one. So we have a mixture of dry solid ammonium chloride. This is solid ammonium chloride. So we have ammonium chloride, NH4Cl, mixed with calcium hydroxide. Calcium hydroxide is CaOH2. So these are heated together. They are heated together. So the heating would result into the formation of water vapor, calcium chloride, and ammonia. So what will remain here in the reaction vessel is the calcium chloride. Calcium chloride CaCl2 will remain here, but water vapor, which is gaseous, and the ammonia. Water vapor and the ammonia will pass through this tubing up to this beehive here. This is called a beehive. Okay, all right. So in order, because we are desiring to produce ammonia, okay, so we need to separate the ammonia from water vapor. So in order to separate ammonia from water vapor, it has to pass through this column. This column is made up of calcium oxide. Calcium oxide has a tendency to remove water. So it will remove the water from the mixture of ammonia and the water. Remember, this is a water vapor. All right, so it will react. The calcium oxide in this part will react with the water, will combine with the water, such that the ammonia gas, which is dry without water, will rise up into this chamber here. So that's in short how ammonia can be made. Ammonia is made or prepared. Mind you, this is just a laboratory setup. It's not an industrial setup. We're going to look at the industrial process in which ammonia is made by reacting hydrogen gas and nitrogen gas. Now, the ammonia that is made has the following properties which I want you to be sure about. One, it is colorless. It is colorless. It has no color. So ammonia has no color. That's a physical property. That's its physical property. It's colorless, and it is also smelly. It has a pungent smell, very strong, choking smell. You cannot inhale it. If you inhale it, you're gonna have a very terrible choke. That's why it is important for you to wear a mask when you are handling a reaction which is producing ammonia. So we are saying it is colorless, 1. 2, it has a very strong smell. 3, it is soluble in water. It is soluble in water. It can dissolve in water. So ammonia can dissolve in water to form ammonium salts and the hydroxide ions. Okay, but anyway, don't mind this. This is not just a basic reaction, it's just dissolution. It can dissolve in water. Suffice to say that it can dissolve in water. Additionally, ammonia is a base, is a basic substance, and you know that all bases will change blue litmus paper to red. So because of its basic nature, it can change blue litmus paper to red. Ammonia can change blue litmus paper to red. Why it does so is because it is a base. It is a basic substance. It also reacts with hydrogen chloride gas to form a white smoke. Such a white smoke is called ammonium chloride. So the smoke is made of tiny particles of solid ammonium chloride. Mind you, these are some reactions of ammonia. So ammonia reacts with hydrochloric acid or hydrogen chloride gas, okay, to form a salt which is called ammonium chloride. Take note, this is a base and this is an acid. It's acidic, okay, especially when it's in aqueous solution. All right, so when a base and an acid react, the product is in most cases a salt. Is a salt. So master the equations so that in an exam you should not struggle to write these equations down. Okay, ammonia also reacts with nitric acid to produce ammonium nitrate. So we are saying ammonia reacts with acids to form salts. For example, it reacts with nitric acid to form ammonium nitrate. Ammonium nitrate is a very good fertilizer, as you should be able to learn in future when we are looking at the applications of these nitrogen compounds. All right. Ammonia is very useful substance in many ways. Ammonia is very useful substance in many ways. It's useful in a number of ways. It is used in making nitric acid. So ammonia can be used to make nitric acid. Nitric acid is simply HNO3. We'll look at this later, how this is done. Ammonia is also used in the manufacture of plastics. It's also used in the manufacture of fertilizers. We just saw here that it can be reacted with nitric acid to produce a fertilizer which is called ammonium nitrate. It is also used in making hard water soft. We are going to see this further in the removal of hardness of water in Form 4. Ammonia is also used in the manufacture of ammonium chloride, which is used in dry cells as an electrolyte. We'll also talk about this later on. Last but not least, ammonia is used in the making of explosives, usually used in making rifles or making of gunpowder or something related with wars. Okay, so these are some of the uses of ammonia. When we meet again in the next lesson, we are going to look at yet another compound which is called nitric acid, which is also a compound of nitrogen. For the time being, allow me to go. Once again, my name is Mr. Pochilola. Don't hesitate to subscribe to the channel and also recommend the videos to your friends. You can share these videos, you can share the link to these videos so that your friends can also join and learn, all for free. Alright, so for now, I wish you all the best in your studies. Bye-bye.